So I hope that helps with understanding of what those occlusion trends are and what an occlusion is and how that looks in ears. Now, to the more interesting thing is if you have an occlusion, or limiting blood flow, that's going to have an effect on your performance, okay? Because we need oxygen and we need blood flow to maintain performance. So this idea of that an occlusion is a bad thing makes sense. We don't want there to be no blood flow. So the idea of, well, how can I train out of them is a rational thought to have. And the straightforward answer is I don't know if you can, if that's possible. So the reason that occlusions happen under high muscle tension, or this reduced blood flow happens under high muscle tension. And if you're doing efforts that require high muscle tension, it's going to be unavoidable that that's going to happen. And you're not going to want to. If you're sprinting, you can't say, well, I'm just not going to sprint as hard to make sure I can maintain my blood flow optimally. Or if I'm squatting or something, it is not going to work. So that's not a valid option to avoid occlusion trends. Now, that being said, if you increase your max strength, you will then, for a percentage of your max strength, be able to push more weight, let's say, and therefore are less likely to be reducing blood flow because the muscle doesn't have to contract as hard. So if you try and follow that train of thought, you can essentially train to have a less reduction of blood flow or have the occlusion happen at a later stage or at a higher weight by increasing this max output. So maybe that's something that we're looking at that we could talk about. So that might be something to consider. Again, if your sport is weightlifting, it's not going to help you because you're going to go 100% all the time. It doesn't matter what it is, and at 100%, you're going to be reducing blood flow. But it helps at submaximal efforts. I think you can get something done there by increasing maximum strength. Another thing to look at, which is maybe more important, interesting for let's say other disciplines, is like technique. So if you are a time trial bicycle rider and you have a really tight hip angle, you're impacting blood flow by your hip angle. So that might be something to consider the payoff between technique and aerodynamics to what's happening physiologically. So you might want to consider your occlusion trends or reducing of blood flow because of your technique. And this might be in a variety of sports like that, where you need to weigh off of what you're doing. That's another point you can make. An interesting discussion that I've had with some cardiologists is the idea of increasing cardiac power, like cardiac output, to keep the pressure up, the blood pressure up, to kind of keep going. Now, this is going to, if it works, would work on the arterial side, not so well on the venous side. Blood pressure doesn't really increase on the venous side, it does on the arterial side. So you may be able to keep pushing more blood in for a higher contraction force. So maybe there's something to be said for increasing your cardiac power or cardiac output to kind of maintain, to get a higher blood pressure. Not super sold on that, but there is evidence that, you have different types of hearts. So you have an eccentric heart and a concentric heart. So you have a heart. Eccentric heart is basically a really big bag, and a concentric heart is you have your heart, but they have really thick walls because it pushes really hard. And traditionally we said, well, that's like the endurance athlete has the eccentric heart. It's just a big bag to pump lots of blood. And the weightlifter has the concentric heart because they got to push really hard because they create these occlusions. They create this reduction of all these blood vessels. So you're always pushing, the heart's always trying to push this blood through. So there might be something there. That data has been a little bit downplayed over the recent years. Some of it has to do with a lot of the data coming out of places where a lot of steroids were used. So it's not so clear that those two types of hearts exist exactly to those extents, but their training will have an effect of how your heart develops, and so that might be something to consider, this idea of cardiac power. Now, to the final point, and this is what I think is the most interesting point. It's your training needs to focus on reperfusion rather than trying to avoid the occlusion. Okay, if you're an endurance athlete and you're a cyclist, the chance of you actually having an occlusion during your cycling, unless you're like really messing around with your hip angle or something, is not that high, because you will not be able to maintain performance if you have an occlusion. So you may have some reductions in blood flow a little bit at high power, things like that. But when we talk about, oh, I see an occlusion in this cyclist, if they're still riding, they don't have an occlusion. The likeliness is very small. Okay, they might have some reduction in blood flow at certain times when they do certain things, but generally you're circulating. Where it's much more likely that you're actually at times really impeding blood flows at real high intensity effort things. Okay, so maybe some time trials. That basically, the higher the intensity effort, the more the muscle contraction, the more likely it is that you're affecting this blood flow. So if, let's say, a marathon runner and a soccer player, I would consider the soccer player has to deal with what we would maybe call occlusion trends more than the marathon runner. And to kind of narrow in on point, what I mean about this training and reperfusion training is that one of the really interesting sports about occlusion trends is rock climbing, because they do isometric holds at very high power outputs, at very high strength levels over and over and over again. And they definitely are impeding blood flow when they're gripping these little holds. And they do it over and over again. And the interesting is that there is some pretty good studies out there that look at climbers and non-climbers. And climbers have and they use NIRS for these. I've done some stuff with climbers myself, and I see the same things going on. So climbers have a much higher perfusion rate, which means in your NIRS signal, the recovery rates are much faster. The rates that they go down, the minimum deoxygenation values are higher, and the rate of recovery is much higher. And it doesn't have to do with the fact that they have more blood flow. That's the interesting part. So there's a study by Fryer, and they check brachial artery. They look at blood flow coming in between the climbers and non-climbers. There is no significant difference. The difference happens locally at the reperfusion rate of the muscle itself. It's the ability of the muscle itself to then take the blood flow, which is the same between a climber and a non-climber, but to reperfuse the muscle with that blood and oxygen coming in. So it's the local function of the muscle as trained in climbers because of the repeated high isometric force, reduction of blood flow, occlusion trends happening over and over and over again with periods of break and then on. Now, if we consider that, that might be the way that you have to, you need to do more training. So if you say, well, I need to do, my sport is occlusion, to go extreme, occlusion, not occlusion, occlusion, not occlusion. Your basic endurance training should be occlusion, not occlusion, occlusion, not occlusion. That's what you're doing. If you're doing some submaximal training, that's not what you're running into in your event. It's something to consider for what your definition of your basic training should be. That's not to say that a climber shouldn't maybe sometimes go for a run or something. I actually don't think they should, but it's not going to have a negative impact. But you need to consider that if you're trying to train out of this occlusion trend, that the better idea might just be to accept the occlusion because it might be unavoidable in your sport, but to be like, how do I train the recovery between my occlusions? That, I think, is the actual approach to deal with this problem or the problem of training out of occlusion. It's probably not possible. It's more possible that you need to deal with how do you recovery, which then come down to strategies of recovery as well that you need to learn. And you need to help your athletes learn what it means to recover out. This is sort of a really long video. It was a great question. I think it's a very interesting question, and I tried to pack a lot in, maybe too much. But if you have any of those points that I mentioned, if there's specific questions to any of those points about how you might train this or not, I can try to pick up on something of that again in a different video. But thank you very much for the question. And I hope this highlights some of that at least. Okay, bye-bye.